Okay, so now we're going to look at quads. We're on number 47, so we're going to look at special quads, and we're going to start with parallelograms. Okay? Parallelograms. Parallelograms have some key qualities. Now I'm going to list these qualities for you, or these characteristics, properties. I'm going to list them over here so that you can see them. I'll move the paper over a bit. Move it up a little bit. Okay. So, number one, the first quality that, or sorry, qualities, goodness gracious, they don't have qualities. You're not going to ask out a parallelogram, are you? Okay, so the first thing is opposite sides are congruent. Okay, we've talked about that. Opposite sides are congruent. The second thing is opposite angles are congruent. Okay, the third thing is the consecutive angles are supplementary, which means they add to 180. The next thing is the diagonals bisect each other. Okay? And the opposite sides are parallel. Okay? So the opposite sides are congruent, the opposite angles are congruent. The consecutive angles are supplementary, the diagonals bisect each other, and the opposite sides are parallel. So I know this is a parallelogram, so if the measure of angle 1 is 72, so let's come to the figure here. And I'm not exactly sure why there's two ones here. It did not come out. Oh, I see. No, I don't see. Okay, I'm looking at this, and it looks like it didn't print well. I don't know if that's supposed to be a 1 or if that's supposed to be a 1. One of them should be angle 10, and I'm going to take a wild stab and say that this is angle 10. Okay, so if 1 is 72, that means this is 72, then the measure of IGE. Now let's follow. IGE. Okay, that's this one. I to G to E. So that's this angle right here. Well, what do you know about the opposite angles in a parallelogram? They're congruent. So using number 2, if that's 72 and that's 30, what is this whole thing? This whole thing right here is 102 degrees, which means this whole thing here must also be 102 degrees because they are crossed and they're identical. Okay? Now the question is, what is the measure of angle 10? Well, for the measure of angle 10, we have to kind of use this. If 1 is 72, do you remember alternate interior angles? Okay? These are parallel lines. So this guy and this guy, sorry, from this perspective, these are parallel lines, are alternate interior. So if that's 72 and that's 12, how do I find 10? Well, what do the angles of a triangle add up to? That's a triangle, right? 180. Here's your triangle. See it? 12, 72, and the angle 10 add up to 180. So 72 plus 12, I'm showing you, is 84. And then, so we want 180 minus 84, which means angle 10 is 96 degrees. So this is 96, okay? Again, I used alternate interior. Imagine that this line and this line are parallel, 72 and 72. There's your alternate interior. Now, if IG is 8, now that I've drawn all over everything, okay, if IG is 8, then what's TE? Well, TE is the opposite, so what is it? It is also 8, okay? Now let's look at the next one, TI, this one right here. If TI is 5x minus 3, and GE is 2x plus 9, then what's TI? Well, what do you know about TI and GE? They're opposite sides in a parallelogram, so they're congruent to each other. So 5x minus 3, which is TI, is going to equal 2x plus 9, which is GE. They're opposites. So subtract 2x, I've got 3x minus 3 equals 9. I'm going to add the 3. Again, this is algebra. I'm flying through the algebra part. So 3x equals 12. I divide both sides by 3. So x is 4. Now, it's not asking for x, it's asking for TI. So I'm going to take this x and I'm going to plug it in here in TI. 5 times 4 minus 3, which is 17. Okay? Now it asks us next, what is the measurement of angle TER? So here's T, if you can't see it, there's T, there's E, and there's R. TER is here, T-E-R. This is TER. What is TER the same as? And I'll mark it differently. This guy. Alternate interior again. Okay? This guy. Ignore me there. This guy. Alternate interior again. So if that's 12, that's 12. TER is 12. Okay? Now the last piece of this is asking you if the measure of angle I. Now angle I, is up here. Oops, sorry, that's T. The measure of angle I is 87. Okay? So it's asking, if this guy is 87, what is the measure of this guy? Well, what do you know about opposite angles in a parallelogram? They are congruent. So since this is T, the measure of angle 1, my bad, it's measure of angle 1. So if measure of angle 1 is 87, then what's TEG, which is this guy, okay? All right, this is getting really sloppy here. So let me redraw this real quick for you, because I'm so artistic. All right, this is 30. We're being told this is 87. We know this is 12. And we want to know what the measure of TEG is. This one. Okay? We know this is 12 because of the alternate interior. What do you know about the neighboring angles in a parallelogram? The neighboring angles add to 180. So this guy and this guy should add to 180. Well, what do we have here? We have 87 and 30. And then what do we have right there? 12. So this angle right here is what plus this equals 180. Okay? Now, I don't need that little x. I want the whole angle. I don't have to get that detailed. So what's 87 plus 30? What do you think? 110? 117? You guys are so smart. So it's 117, right? Okay? So don't worry about this. I don't need to know the individual x. I just need to know what together these add up to. What's 180 minus 117? 63 degrees. So this angle has to be 63 since this one is 117, because what do the neighbors have to add up to? 180. Now if I wanted to know this little guy right here, this x, then I would have to use this equation and solve for little x. But it doesn't want that angle, it wants the whole thing. Okay, so that's some of your parallelograms. Now, if we go on this side, kind of watching the battery here on my deal. Let's look at rectangles. Okay, flat. Flat is a rectangle. Okay, flat is a rectangle. So if it's a rectangle, remember it has all parallelogram properties. So it has all parallelogram properties plus 4 right angles and congruent diagonals. Congruent diagonals. So now the diagonals are congruent because it's a rectangle. So if the measure of angle 1 is 48, what's the measure of angle 4? Okay, well, in this rectangle, if this is 48, what's its neighbor? Well, they're all right angles. So that has to be 42, right? okay? But if you look at this carefully, if that's 48, what's this? It's 48, because those are alternate interior angles, right? Okay, those are alternate interior angles. So these are all 90s. All right, so I've got 48, all right? So the question is, what is angle 4? How do I find that? Okay, well, what do you know about the diagonals? Everything is symmetrical. This is 42, if that's 42, in a rectangle. The diagonals create symmetry. So that means that this one here would also have to be 48. So 4 is 48, okay? If the measure of angle 9 is 27, so if this guy's 27, what's the measure of angle 5? Well, if that's 27, and you want to find the measure of angle 5, you know that that adds to 90, and that's 90. Well, what do we already know this one is? That's 48. So this is also 42. This is also 42. Okay? But look what happens. I have 84 and 27. That doesn't really work, right? So what they're telling us is don't use the previous values. But what we do know, so ignore all of these. These are all out. But what do we know about these two angles? They're symmetrical. That and that are equal. So I know that 27 plus 2x is equal to 180, because isn't that what a triangle adds up to? Okay, hopefully you can you not see my work down here? Where am I? Right underneath. Okay, so I'm going to subtract a 27, and I've got 2x equals 153, and I'm going to divide both sides by 2, and I get 76.5, I believe. So 76.5 degrees. Okay? So now it starts you over again. That's the hard thing about me sitting here using all these colors. All right, let's start over again. So I'm going to cross out everything again. The measure of angle 4 is 82. If 4 is 82, sorry, what's 9? Well, again, if 4 is 82, 5 has to be 82, because those base angles are the same. The three angles of a triangle add to 180. So this plus this plus this have to add to 180. That's 164, which means this is 16. And what do these make? A linear pair. So 16 taken away from 180 is 164. So 9 would have to be 164, because those make a straight line. Okay? All right, so let's cross them out again. We're not using these guys. Now we're down here to D. If 7 is 16 degrees, and the length of LA is 28, that's the length of this side, then what is LT? Well, here we come with the trig. Okay, we're coming in with the trig. I've got a 16-degree angle here. Do you see my right triangle? I'm going to put blue all the way around it. Okay? I know this one, and it wants LT. It wants this one. So I've got opposite, and I've got hypotenuse. And remember, from your trig, that's sine. So the sine of 16 equals 28 over x, which is my hypotenuse. So I'm going to do sine of 16, and then I'm going to do 28 divided by that. Oops, where'd it go? And I get 101.5. Okay, so sine of 16, so 28 divided by sine of 16, and I'm going to verify. Yeah, 101.6. So LT is 101.6. That's how long it is. And again, you're using trig. Okay, sine of 16, because I know the opposite and I want the hypotenuse. All right, let's look at E. E, if FL is 12, okay, so if FL is 12 and FT is 16, then FA is what? Okay, here's FA. All right, well, since it's a rectangle, since FL is 12, what's this? It's 12 also, right? So I've got 12, 16, and I'm just looking now for the hypotenuse. So I use the Pythagorean theorem. And so to use the Pythagorean theorem, I'm going to go over here, I'm going to do 12 squared plus 16 squared equals x squared, because I'm looking for the hypotenuse. And then I'm just going to work this out for you. That'll be 144 plus 256 equals x squared, and that's going to be 400 equals x squared, square root both sides, so x is 20, which means that would be 20. Okay, again, you're applying everything you know about rectangles here. Okay, we're kind of running out of time here. FA is 72, so now let's make sure this is, we're going to say that's 72. Then what's TO? And TO is this one. Well, what do you know about the diagonals in a rectangle? What do the diagonals of a parallelogram do to each other? They bisect, right? Okay. Well, if this diagonal, if FA is 72, that means this diagonal is also 72. And since it's a parallelogram, they cut each other in half. What is half of 72? So TO from here to here would be half of 72, which is 36. Okay? And that's what we have for the parallelogram part. I'll do the rhombus and the trapezoid on the next video.